Hi everyone, welcome back to the channel. In this quick video, I will show you how to calculate the hot water circulation pump flow rate for a villa project at the tender stage. This basic method gives you an idea of pump capacity for early design. For actual project execution like high-rise building, mid-rise building and actual execution, you must calculate heat loss for each pump, each pipe size. Like if you have 20 mm, 25 mm, 32 mm, you have to list each pipe size separately, and for each pipe size you have to record the exact length in meter and you have to consider the heat loss per meter. That is a detailed procedure we have. I will show this procedure also in the upcoming video. So in this video we are going to see the basic method which gives you idea of the hot water circulation pump calculation for the yearly design. So here we have a G+2 Villa in the UAE. So in this project, we are going to use a PPR polypropylene random copolymer pipe for both hot and cold water. Additionally, for the hot water, we are using the insulation for the PPR pipes. So this project location in the UAE. So the total, as you see here, the total length for hot water pipe, including the supply and return, is 200 meter. Now, the important thing we need to consider is the heat emission from the insulated pipes. In order to find out the heat emission from insulated pipe, we are going to refer one important table from ASHRAE application handbook. So, like you see here, I will just zoom this one. ASHRAE handbook HVAC application service water heating. So, like we can see here, and a rough estimation can be made by multiplying the total length of covered pipe by 30 watt per meter for our uninsulated pipe by 60 watt per meter. So in this calculation, we are going to use the 30 watt per meter pipes, the cover length of covered pipes for this insulated PPR pipes. So from this formula, from this ASHRAE application reference, I'm going to consider 30 watt per meter for the heat emission from insulated pipes, and the total heat loss in supply and return pipe. As you know that we already considered 200 meter for the supply and return total pipe length irrespective of the pipe size. So there are different pipe sizes, 20 mm, 25 mm, 30 mm, different pipe sizes are available. For this early design method, I'm going to consider only the total pipe length irrespective of the pipe sizes. So I'm going to multiply the both through. So you will get 6000 watts total heat loss in the supply and return pipe work. And with this one, I'm going to add the safety factor of 10%. So you can see 6000 watts and multiply with 1.1, you will get 6600. So now I'm going to apply the actual formula that Q is the pump capacity in liter per second is equal to, you can see this formula. So in this formula, I have used Q by rho is the density of the water, like you see here, density of the water, and Cp is the specific heat of water, that is 4.186, or you can see this unit 4186.8 joule per kilogram Kelvin. And here delta T, the allowable temperature drop. So this is one of the important thing, the allowable temperature drop, what we consider, because everyone has different aspect for this delta T. So normally what we do, for the delta T is like a 5 degrees Celsius. For villa or low rise residential where we have the shorter pipe runs, the comfort is a top priority. For I mean the instant hot water at taps. If you open the taps very shortly, we need to get the hot water receiving point. Then smaller system volume, the faster recirculation needed. So for the smaller system volume, this for the short pipeline where we have the small system hot water volume. So this type of area we normally consider delta T as 5 degrees Celsius. So if you apply all these values in this formula, you can get the answer. So now we have here the heat loss that already we got the answer 6600. The density from here we are going to apply, and Cp from here we are going to, sorry, density from here we are going to apply, and Cp from here we are going to apply, and also delta T we are going to apply 5 degrees Celsius. So if you add all this answer, you will get the answer of 0.3185 liter per second. So here you can see I added all this answer from the formula. So you will get the answer of 0.318 liter, 85 liter per second. That is the calculated circulation pump flow rate. So as I told you earlier, this basic method gives you an idea of the pump capacity for the earlier design. In the future, I'm going to post one detailed video for you which explains that how to find out the hot water circulation pump for the high-rise building considering the each pipe sizes and heat loss. So thanks for watching. Like, share and subscribe for more practical MEP design videos.